This is Josh Mandel back with another episode of a guided walk through FHIR. And we're going to continue where we left off with the FHIR safety checklist. And so this is what we had been working on. This is the safety.html page. And in the last sessions, we've been through items 1 through 4 on the checklist, which brings us today to the following. My system has documented how distributed resource identification works in its relevant contexts of use, and where and why contained resources are used. So these are two big topics. We're going to do our best to take them on at least briefly in this session. And so we'll dig in first with distributed resource identification. What to say? First thing is that FHIR resources are designed to be used as part of a graph. So I might have one medication request resource here representing a prescription, but it points to lots of other resources in order to communicate what it needs to. So it points to a patient to convey who the prescription is for, and it points to a practitioner to indicate who wrote the prescription, and it might point to an encounter resource to indicate the context or the encounter in which that prescription was written. So naturally, FHIR resources form a kind of a graph. And the typical situation is this whole graph sort of exists within the context of a FHIR server. And so I might have a FHIR server based in one hospital or health system that's got a set of medication orders and all their related patients and encounters and practitioners and organizations, and that server sort of tells a coherent story with links between the resources in its own namespace. And that is the most common way that FHIR resources and the links between them can be established, but it's not the only way. So actually in FHIR, anytime a resource points to another resource, that could be a resource hosted on the same server as the original resource. It could be a resource hosted somewhere else, like out on a server maintained by a different organization. And so that's what FHIR would think about or would call a distributed resource management kind of scheme. So here's what the spec has to say about resource IDs. When a resource is living on a given server, it has an ID, what's called a logical ID assigned to it. And so if I'm talking about /patient/123 as a FHIR resource on my server, well, the logical ID is that 123 piece. It shows up in the FHIR resource ID. So let's read through this. When resources are exchanged between systems, they may need to have new logical IDs assigned. When a resource has a new logical ID, nothing in the resource changes other than the resource.id. So what this means is, like, let's say I'm posting a resource from my system to yours. Maybe I'm going to tell you about a patient that I've got in my system. You don't have it in your system, so I'm going to post a new patient record. I don't know what FHIR logical ID the target system is going to assign. That's really up to the target system. Maybe they already have a patient that they call 123, but it's about a totally different individual than the patient that in my system I know as the logical ID 123. And that's because logical IDs are always interpreted relative to a FHIR base URL. So if my base URL is different from yours, my patient 123 could be different than yours. 123 only makes sense in the context of that base URL. And that's really important for the story about distributed resources because it means each server is effectively in charge of allocating names from its own namespace, allocating logical IDs from within its own patient or observation or medication request resource namespaces. What this means, though, in FHIR is, of course, resources make a graph. And so if I want to post a patient to your server, but I also want to post a medication request for that patient to tell you what medications they've been prescribed, well, the link between those resources needs to be updated to reflect the logical IDs that the receiving server wants to assign. So let's look at that more concretely. Let's look in the FHIR core spec here, and we'll open up, let's just say, the medication request resource. And in this context, a medication request has a link to lots of things, including the subject, which is generally a patient. could also be a group. So let's look at an example of one of these just to make this concrete. So we'll try to look for something relatively simple. Say active request of the code. We'll look at the JSON value for it. And so this medication request could have some notes and some dosage instructions and a reason for the prescription, all this kind of information. But here we go. We've got a subject which is a reference to patient/pat1. This is like the patient/123 I've been giving in my examples here. What this means is if I want to post this medication request to your server and I also want to post the patient record, I need to make sure that the links all line up so that at the end of the day, if your server calls this patient 567, well, the medication request also needs to point to patient 567 in order to make sure that those links are coherent on the other side. And there's a few options for doing that. As a client, I could send them one at a time, starting with the targets of the links and sort of working my way backwards. I could also submit a transaction bundle to a server and say, here's a small little subgraph of related stuff. You don't know about any of it yet, but I'm going to tell you about a patient and a prescription. You go and sign the IDs, and you, the server, can take care of updating all the links to make sure that they're coherent by the time that you save the results. So those are a couple different stories for how a small graph of resources can be copied from one server to another, even if these resources IDs are updated. And so that's the basic thing to think about when we talk about copying resources and assigning new IDs. But there are other scenarios that are possible as well. So one that the spec calls out is a client could retrieve a resource from a server and make its own local persistent copy, managing its lifecycle independently. And here, again, the client might be assigning new IDs to these things. There are some cases where it's really important, even though I'm spreading information about this patient to many different servers that are each going to manage them independently, in some cases it's still really helpful to assign a stable identifier to that resource. And so there is a tool that FHIR provides for this. Let's read on. We say in some cases a client might need to deal with multiple servers. I'd say actually it's a pretty common case. And in this case the logical ID is not guaranteed to be unique. If the client can't be sure that the resource identities are unique, it might have to assign new IDs, and it might have to manage some kind of lookup table. But what I want to highlight is that there's another tool that clients can use in this space, which is not the FHIR logical ID, but the FHIR identifier. And so if I want to talk about a given prescription, the logical ID might change as it gets copied around from server to server. Each server assigns it. But I can also provide potentially 0 or more identifiers on that medication request. And those are meant to be kind of stable, that would travel along with it, so that if you've got a business identifier or an external identifier for this particular resource, that identifier or those identifiers can travel along with it. And then when I'm looking data up, I can use those identifiers as kind of a common or stable basis. And so this is the FHIR data model for identifiers. We won't go into it in a ton of detail, but it's one of the complex data types in FHIR. And at the core, an identifier has a system and a value. So whoever is assigning these identifiers would typically create a namespace that represents the assigner, and then would assign a value. And so in the case of a medication prescription, you might see the system representing a hospital or health system that created a prescription, and you might see the value representing some kind of a unique, stable identifier for that prescription. And the great thing about identifiers in FHIR is you can typically put a whole list of them on any given resource, and they can travel around with that resource independent of the logical ID. So even if the resource moves from server to server, it can still maintain that set of identifiers. I'm going to do a quick search on this page that we're looking at from the safety checklist. See if what else we might be missing here. So yeah, actually the safety checklist linked us down to this section about working with multiple servers and managing resource identities with copying new IDs. But actually the top of the page has some really important background, and this is where we introduce the concept of identifiers in addition to these logical IDs. So that's a bit of background on managing resources in a distributed system in FHIR. let's take a look at contained resources. So contained resources are kind of a neat trick that FHIR has, and maybe one of the most tempting features to misuse. What do I mean by this? Well, contained resources provide a way to embed one resource inside of another. And so if we look at an example in JSON here, I might have a condition resource, which is going to tell you something about a diagnosis or problem on somebody's problem list. And that condition would typically have a link to a patient or the subject of the condition. And it would typically have a link to the practitioner, maybe who asserted the condition. So normally we'd find a reference here to something like practitioner/123. And that would say, to know more about who asserted this condition, go out to the FHIR server, ask them about practitioner 123, and you'll get back somebody's name and address and qualifications and maybe their license numbers and the languages they speak and this whole sort of payload of data about the practitioner. That's the typical scenario. But what you see here is instead of a link to an external practitioner resource, you have a link that starts with a hash sign. And that tells you it's going to be an internal link to a contained resource. And every FHIR resource can have an array of contained resources inside of it for just this kind of case where you can't provide, you don't know a stable identifier or logical ID for this practitioner that lives on a server somewhere. And so you just embed the data about the practitioner. So in this case, all you might know is that the person's name was Patricia Person. So the trick here is designed to be used in a very limited scenario. You would only ever use a contained link if you didn't know enough to properly identify this practitioner or to properly identify the resource at the target of this link. That's the only case where you're supposed to put contained information inside of a resource this way. But I mentioned it's very tempting to do more. And the reason is that oftentimes implementers look at this contained array and say, well, actually, this is going to be a great trick so that instead of having to go back and forth to the server with multiple requests and figure out the links across them, I could just create kind of a package of all the resources that I need in this self-contained way, all embedded inside of my condition, so that the resource and all of its dependencies are pulled together in a single set. If you want to do that in FHIR, there's a couple of warning bells that go off. The first thing to say is take a look at the bundle resource. The bundle resource is generally the way to provide a small subgraph of resources that have some interdependencies. So if you want to tell a story about a condition and the practitioner and the patient and send that whole story from point A to point B, the bundle resource is the way to do it. Even though technically you might be able to shoehorn a bunch of stuff into this contained array, the FHIR methodology not only recommends it, but in general prohibits that. And so what we say is, in only very limited circumstances would a resource be placed directly in line within another resource. That shouldn't be done if the inline content could be identified properly. And we say the FHIR version of a contained resource shall always be the same as the resource that contains it. I think that's a point about like FHIR R2 versus R3 versus R4. You can't contain an R2 resource inside of a FHIR R4 resource or something like that. So this is pretty strong guidance, but it's not an outright prohibition as I read it right now. It's something that we have a lot of discussions about on chat.phir.org in the implementers channel, because as soon as developers see this capability, they tend to want to pick it up and use it, even in places where it's going to prevent downstream management of the data. Because when I send you information about a practitioner that's all wrapped up inside of a condition, that makes it really hard to review and verify and update details about that practitioner later. So maybe you want to have a data quality program where you're going to go and check NPI numbers for practitioners. And that's much easier if you've got a kind of normalized practitioner database where everybody's represented once and you can make an update and be confident that it's going to take the effect you want. But if your state is denormalized or spread in a whole bunch of different places, and in some spots all you've got is a name, and in other spots you might have a name and an NPI number, suddenly every instance of this is being managed separately. And it can be very hard to line things up and improve data quality. And that's part of why this is called out in the FHIR safety checklist. So that's a very quick introduction to a couple of deep topics of representing graphs of resources in FHIR. There's part of the story about distributed resource identification and how one server can manage its own state that sort of reflects what's stored in another server somewhere else. And then when it comes to conveying sets of information together, the very limited circumstances where it might make sense to use the contained resource feature, and some of the alternatives like bundle that you should probably consider if you find yourself leaning on contained or if you find yourself tempted to do so. So we'll wrap up there. That's been step 5 on the safety checklist for FHIR, and I'll see you again next time.